to another video of CAT channel. Today we discuss regarding the earthquake resistant buildings. So before beginning that, we will see how the earthquake acts upon a building. All the buildings we know are designed for vertical loads or based upon the gravity it is designed. But when the earthquake happens, the force acting or the force comes from the horizontal side. See, if this is the building and the force comes from the horizontal side only. So if it acts on the building, then the building will collapse or it will make cracks in the building. So there is a high chance for the building to collapse. So in order to prevent such a thing, what we have to do is we can go for isolator foundations, in which the building will be isolated from the foundations. Okay, that is called isolated foundations, or flexible. We are go for the flexible foundations. The flexible foundation will not be rigid like the usual foundations that we provide for buildings. So here, look at, this is the building and this is ground floor, ground level, and this is the foundation part. So this is an isolator or a flexible pad. You can say it is called a flexible pad, which consisting of steel, rubber and lead. So with this material, if you do that, when the earthquake happens, the force will comes horizontally and it will act upon this, and these two part will move like this, but keeping the superstructure and the base intact. So a very little force will be exerted on the main building. That means the horizontal force will not be transmitted to the vertical building above the foundation. So this is called isolated footing or flexible pad, which we are using in many of the multi-story buildings. And usually, nowadays a lot of earthquakes are happening throughout the world, especially in India. If it is, we can say most of it happened in North India and in Nepal and in northern part of India, northeast. So many of the buildings are adopted it while they are doing the foundation itself. So if they don't care much about the earthquake at that time, then it may be a problem in the future for the building. So this is the flexible foundation part where we are using the flexible pad consisting of steel, lead and rubber. Okay, and this is one of the solution. And the second solution is we can shield the building. When the earthquake happens, just like I said, the seismic forces comes in the horizontal direction and it acts upon the building. So if you provide a shield across the building like this, if this is the building and this is a shield around the building, which we are putting, which the material made up of it is concrete and plastic, and this we will dig up to 3 feet below the foundation part. So when the earthquake comes from this side and this side, it will come into the first ring and then it will get deflected. And if the earthquake is a bigger earthquake, then it may go to the transverse to the second ring, and there it will get deflected and the seismic wave will not reach the building. So this is the second type of earthquake resistant method that we can provide for resisting earthquake which comes into the building. Okay, so this is a very expensive thing, because around 100 rings we have to make beneath the foundation up to 3 feet, consisting of concrete and plastic, just like I said before. So this is the second part of it. And the third part, for a very high-rise building, maybe consisting of 50-60 stories. Okay, we are providing the pendulum method, and this is called the pendulum method. Pendulum method means in the top of the building, the utmost top of the building, they provide a board with the steel cables and with a hydraulic system, so that when the earthquake happens, the force will act upon the horizontal force will act upon the building, and this will directly transmit through the steel wires into the board, and the board will swing in the opposite direction of the earthquake, so that it can balance with the swaying part, so that it will balance the building. So most of the forces will take by the board and it will sway into this side, so that action will take all the forces by the seismic waves upon the building. So this is the pendulum method which we are using for high-rise buildings. Okay, this is the third method. And then there are other kinds of methods where we can control the vibration of the seismic forces by the use of some devices. And one such device is called dampers. So in many of the buildings which I worked in outside India, they are providing dampers. So what is called damper? Damper is actually like this. See, this is a building and this is the earth level, and the damper is a piston-like thing which they provide in between the beam and column. In between beam and column, they are providing the dampers diagonally, and in that steel structure, they will provide a piston like this piston. This is a piston, and this consisting of oil. Okay, so when the horizontal forces act or the seismic forces acts upon this building, that force will transfers through this steel structure, which comes in between the beam and the column, and it then goes to the piston, and the piston will move forward and compressing the oil in it. And when the compression of oil happens, that will convert into the heat energy. So the whole seismic forces or waves forces will be energy will be converted into heat energy, and it will get dissipated. So that's the way by which the damper is acting when the earthquake happens in a building. So this is a very widely used thing which we are providing in most of the multi-story buildings. Okay, that we are providing in North India, Nepal, and many other countries. This is a usual thing when they are doing the buildings along the structure. They are providing this type of things, piston and oil. Okay, and then we go for shear bar. You might be heard about, and we are also very much well aware of the shear bars that we are providing in the lift. Anyway, when there is a lift, there will be shear walls around the lift, and of course there are shear walls around the building too. Building where the structural engineer designed that there should be a shear wall there, and this shear wall will also help to reduce the earthquake. If the earthquake happens and the vibrations, it will reduce. It consumes most of the seismic forces. And also shear wall and diagonal cross braces. This is like this building consisting of a shear wall here, and this is diagonal cross braces. So these diagonal cross braces are steel structures which can take compression as well as tension when a seismic force acts upon it, and the building sways like this. This cross braces will take most of that forces if it is compression or tension too, and along with the shear wall. So shear wall also will take seismic forces. So this you can, when you are attending an interview, you can say that you have to provide shear wall to resist earthquake. And then another method is providing horizontal frames. That is, this is a building, and this you can see we are providing beams across it. So when there's an earthquake happens, that force will go through all the structures, but this beam will also take that horizontal force, and it will help the building to resist earthquake to a certain extent. Okay, and then another method is that while constructing the column and beam, we can give moment resisting frames. Moment resisting force means if this is column and this is beam, you can see this is a steel structure where we can provide it through the joint of the column and beam. Okay, this will go in through this joint, and it will end here. So when a earthquake happens, this column and beam may bend. Okay, but the joint will be rigid because of this structure. Because of this structure, the structure will take all the forces, so it will help this joint not to move or not to bend, except beams and columns. It can bend, but this will not be bent because this will act as a rigid surface because of this moment resisting frame. So this is another method. And apart from this, we know we can use many of the earthquake resisting materials. So if you use that, it will also take the earthquake to certain extent. It will help the building to resist earthquake to certain extent. And some of the earthquake resisting materials are structural steel. Like I said before, structural steel also takes some tension and some compression to some extent when the earthquake happens. Another is wood. If your building is made of wood, then there is less chance of that building to collapse in an earthquake when comparing to a concrete structure. So it means the wood as a material will take the horizontal forces. And then the memory alloys. Memory alloys, if we are using memory alloys to make a column, then what is called memory alloy means when you can see the nowadays many of the car being made up of memory alloy material, so that when it get crushed, the frame will go inside because of that crush, and it will come outward. As the force goes off, it will automatically comes to the original shape, like you can see in the Benz car. The same thing is using memory alloy. So if you use that thing in the column and beams of the building, it will come to the original shape. After the earthquake happens, it will come to the original shape. So these are some of the techniques or the methods that we are using to resist earthquake building. And along with that, I will say, when you are doing the column of a building, it's a vertical tie also we have to put in a 135-degree angle. And also in the beam also, in the stirrup also, we have to put the stirrup, the hook should be into 135-degree angle, so that it will resist the earthquake to a certain extent, and it will keep the concrete and the steel intact. So this is also one of the things which we have to do when we are doing the structural part of the construction. So I hope I have covered most of the things which are methods to resist earthquake for a building. So I will come with another video with another subject. Hope you like this video. If you like, please share, subscribe and like. Thank you very much.